Section 2. Little influence, mixed evidence. Quantum theory received its initial substantial formulation as long ago as the 1930s. Hodgson asked why it has received such little consideration from philosophers of mind, computer scientists, and brain scientists. He offers two general explanations. First, it may be that the principles of quantum physics are not widely or well understood by workers in those other disciplines. Secondly, there are deep disagreements among physicists themselves as to the implications of quantum physics. In addition, Hodgson points to several specific aspects of the new physics which, even when carefully examined, tend to discourage any idea that quantum processes might account for independent mental causation. He lists three such general reasons. Firstly, it's assumed that quantum indeterminism is only relevant to the predictions of micro-events. Secondly, this indeterminism doesn't have any effects at the macro scale, for example, on brain cells, and for this reason is irrelevant to mind and consciousness. Thirdly, even if quantum indeterminism did have any effects in the brain, they couldn't play any role in producing the sort of coherent human consciousness we experience, because quantum processes are unpredictable and random. In addition to specific arguments against any quantum effects on mind and consciousness, the new physics has also had to contend with its general bizarreness compared to the familiarity of classical physics. As Dana Zohar says, the Newtonian categories of space, time, matter, and causality are so deeply ingrained in our whole perception of reality that they color every aspect of the way that we think about life. Each time that we drive a car from one point to another, we are, to some extent, conscious of the space between the 2 points and the time it takes to travel between them. The simple act of opening and closing a door makes us subliminally aware of the material being of both the door and our hand, and of the cause and effect relation between them. How then do we deal with a claim that there is no space between separate objects, indeed that there are no objects such as we normally think of them, and that the whole notion of separate has no foundation in reality? This ingrainedness of classical concepts may not only be embedded ontogenetically in each individual's experience, but it may also have a long phylogenetic history. Mithun talks about this as intuitive physics. He says, from a very early age, children understand that physical objects are subject to a different set of rules from those which govern mental concepts and living things. It appears impossible for them to have acquired such knowledge from their limited experience of the world. Concepts of solidity, gravity, and inertia appear to be hardwired into the child's mind. While the life experiences of a young child are dominated by that of people, they nevertheless understand that objects have fundamentally different properties. They cannot, for instance, cause action at a distance, as a stranger can do when he or she enters a room. Again, a conclusion contradicted by quantum mechanics. As an example of a strategy for dismissing quantum theory in relation to consciousness, Margaret Borden and others simply contend that the randomness of quantum phenomena obstructs and undermines human freedom and responsibility. Dennett, however, takes a more nuanced approach to randomness. He suggests that quantum indeterminacy could, in a random manner, produce possibilities, some of which an agent could reject as irrelevant, while others might enter into a deterministic reasoning process. However, he also says that there's no greater value for genuine quantum randomness than for pseudo-mechanistic randomness, such as can be generated in computers. Similarly, Christopher Koch states that indeterminism provides no solace for the true libertarian. It is no substitute for free will. Surely my actions should be caused because I want them to happen, rather than happening by chance. Trading the certainty of determinism for the ambiguity of randomness is not what Descartes had in mind. The libertarian conception of the mind requires that the mind controls the brain, not that the brain decides capriciously. Similarly, Borden writes, synaptic activity may or may not involve indeterminacy at the quantum level. Even if it does, the unpredictability of human behavior would not thereby be vindicated. Indeed, a radical indeterminism at the origin of action would be incompatible with human freedom and responsibility rather than essential to it. Christopher Koch makes additional comments on the speculative quantum consciousness link, going right back to the original Copenhagen interpretation, which he says postulates an intimate link between consciousness and which quantum event among many actually occurs. The notion is that a sentient human observer, whether a monkey would do has never been considered, is required for the possibilities that quantum mechanics deals with to collapse into one or another actual outcome. He goes on to say that more recently, the debate has centered on entanglement, the well-verified observation that certain carefully prepared quantum systems remain mysteriously linked, no matter how far apart they are. Entangled quantum systems, such as two electrons with opposite spins moving away from each other, or two polarized photons, will always be correlated, no matter how remote they are, as long as they don't interact with anything else in the interim. As soon as the spin of one electron is measured, the spin of the other is determined instantaneously, even though it may be a light year away. As Koch says, entanglement is weird but true. One of its weirdest features is the implication that one particle of an entangled pair knows what measurement has been performed on the other and with what outcome, even though there is no known means for such information to be communicated between the particles, which at the time of measurement may be separated by arbitrarily large distances. As Koch explains, the physicist Roger Penrose and the anisotologist Stuart Hamerhoff and others have speculated that this otherworldly non-locality is closely linked to consciousness. Strands of Buddhism, a much older tradition, likewise argue that object and subject are inexorably linked and that consciousness is a fundamental feature of the physical universe.